And we are live. Good evening, everyone. Welcome to the live chat for Wednesday, July 16th, 2025. Before we begin, just want to give you guys a heads up. There's literally a severe thunderstorm pressing down on us, get ready to move through. So there is an outside chance that we could lose power and lose internet. Well, we have a generator, but you never know with the internet. So we'll have to watch that very carefully to make sure that doesn't become an issue. So if I automatically disappear, that's probably why, because we lost power. So we have a lot of stuff to talk about tonight. We have some mischief in the Gulf, so we're going to start with that. Also, we have a book of the week, and we have the address so you can go check out the book. And I have a link, and I also have a definition of the book and the name of the book, Field Guide to Weather by Ryan Henning. This is a great book for someone who is just starting out and wants to learn stuff like what is a thunderstorm, what is fog, how does fog form, what are the different levels of the atmosphere of cloud cover, the changing amount of daylight, basic meteorology, but a lot of good information. What is a cold occlusion, the different types of frontal structures. So this is a great book to get if you have someone who is, let's say, I say the sixth grade, or even the seventh grade, somewhere in that fifth to seventh, somewhere in that realm, just as a starter, in terms of frontal structure, cloud formation, levels of clouds, names of clouds. Excellent book. Check out the link in the bottom in the description. So definitely check out that book. So that is the book of the week. So let's dive into the data. We'll start off with the tropics. Boy, oh boy, did a lot of people get a lot of hype out of this tropical disturbance. All sorts of people running around talking about hurricanes and all this other nonsense. In reality, you never want to forecast for a organized tropical low pressure system until you actually have the circulation, because otherwise, you can end up looking pretty foolish. And that is essentially what is happening here. We have a tropical disturbance. The only problem is that the low level circulation is basically skirting the coast, and there's really no sign of organization. Now, you might think all the convection is here, but in reality, it's back here. So, let me try and circle this here. So our circulation is right about there. All the convection's over here, and you kind of see like a twist in here. Oh, sorry, right there. What that is the mid-level low pressure system. So it's kind of sheared and broken apart. There's not a lot of organization to this. I honestly believe that this becomes just a regular tropical low, and not an organized system. I don't think we see a tropical depression out of this. The APM update came up and it's only at 40%. So I don't really see anything significant coming out of this. And the rest of the tropics are quiet. So that's certainly some great news. Again, I think if there's going to be significant development this year, it's going to happen around these stationary boundaries off the coast, around the Bahamas, that we really have to keep an eye on. And my primary concern is the potential for heavy rainfall, because this weather pattern isn't changing anytime soon. Of course, with the weather pattern, we talked about this morning. This isn't changing. And so, as long as this doesn't change, then guess what else doesn't change? The EPO. So right now, this is our traffic cop, right? That I've been saying for quite some time. This isn't changing anytime soon. So basically, a negative anomaly. You'll probably have a little bit of waving towards positive from time to time, because it's impossible to stay negative for 4 months straight. But what this basically means is that what you see is what you get. Okay. This pattern isn't changing anytime soon. We'll talk about the fall in just a moment. But I want to get to the thunderstorms right now and kind of go over that while I get myself some water. Okay, so we have thunderstorms all over the place. And we have one that is moving right over Freehold very slowly. Don't be surprised if this starts to shift over to a flash flood warning, because these thunderstorms are moving very slow because the mid and upper level winds are very weak. But what's causing all of this ahead of the stronger shortwave that is off to our west. So when we zoom out here, you can see a lot more rainfall and some thunderstorms. This is all associated with a shortwave that is approaching. But what's the deal with all this? Well, take a look at the low level winds here. This is really, really cool because this is a great example about how small mesoscale boundaries can create these thunderstorms in very humid tropical environments. And right now, the rain is really coming down hard. The fireflies seem to like it. They're all coming out, but I'm just looking out the window right here, right out our door. It is like a waterfall going on right now in Freehold. So I would not be surprised if we get a flash flood warning out of this, the way that it is raining right now. But take a look at these little boundaries here. Let me see if I can circle this and see. Okay, so you have a convergent zone right here. You have a divergent zone here. Okay, and this convergent zone is setting up all these thunderstorms that have evolved. So we get this out of here so you can see it a little bit better. Okay, so we're going to zoom in on these winds, and you see these little pockets here. Now you combine this with the orographic factors. There's actually in terms of central Monmouth County, there's a little bit of bowl right here, right? A little bit of lower elevation right in here. You have higher elevation up here. So you're having these low level winds converging. And what's happening here is that this low level convergence is lifting the tropical moisture. Now you combine that with outflow boundaries, which is basically cooler air coming out from thunderstorms that were occurring previously in the afternoon that was developing right along the Monmouth County coast. And that is how you end up with all these thunderstorms firing up here. We'll zoom back in. And I tell you what, we'll take out the overlay for the watches and warnings for now and just show you. Notice this is all lined up exactly where the convergent winds were. So you have this boundary here from the previous thunderstorm, and then you have this convergent boundary here that's driving these storms. And the combination of these is allowing for all this lifting of tropical moisture. If we did not have the deep tropical moisture that we have in place right now, which we can see right here, precipitated water values at 2.2 inches, that's a lot of moisture for this latitude. Okay, that's impressive. Okay, so you're getting this moisture gradient. Wow, it is really. If you're driving in this, well, you shouldn't be watching this if you're driving, obviously. But if you're going to be driving, I would use extreme caution in this environment because of the heavy rainfall. And then you got this area lifting here. So what's with the thunderstorms for tonight? Well, that's all driven by this divergence and diffluence here that is driven by this short wave here. So again, this is totally separate. What's happening right now over central New Jersey is totally separate from this actual short wave because the lifting from that short wave is all focused here, which goes back to this. So this is all driven by the shortwave. This is all driven just by simple mesoscale boundaries interacting and lifting a lot of tropical moisture. That's it. That's all you need. This is why in the forecast, I've been saying isolated to scattered showers and thunderstorms. Why am I not being more specific? Because I can't tell a day or 2 or 3 days out where these mesoscale boundaries are going to interact, right? No one can. So when you have this type of interaction, you have all this moisture in the atmosphere, you can end up in a scenario where, for example, Freehold gets over an inch of rain very quickly and Manalapan gets next to nothing, right? Which is the town over. So this is an issue that's going to be a frequent problem as we continue on through the summer. And right now, the way that we're going and the way that the water table is becoming saturated, the reason why I keep on bringing up, hey, watch out for any type of tropical system around the Bahamas, is that we're setting ourselves up for a major flash flooding event if we get any type of remnant storm up in this neck of the woods, because unlike beforehand where we had a drought and there was some time for the water table to absorb a lot of this rain, we are moving away from that and moving to a scenario where, hey, we have had plenty of rain, we're running above normal, is basically the exact opposite of what we saw last year. So while all this is going on, this shortwave will be approaching tonight, and this will open up again the potential for more heavy downpours. Not a lot of severe weather, but if we do see a severe thunderstorm, it's going to be via downburst wind gusts, because again, you're lifting all this tropical moisture and then it raises up into the mid levels of the atmosphere where you have drier, colder air. It condenses, cools, and slams back towards the ground. So that is where we're going to see that severe thunderstorm potential. As you can see on the water vapor satellite picture, there is no shortage of tropical moisture to lift. And then this feature here is the next threat that we're going to be watching for on Sunday. That will introduce the potential for more widespread showers and thunderstorms for our neck of the woods. You can see the lifting here. It's pretty impressive, pretty robust here, getting ready to move into our region. This is kind of like the appetizer, what's happening over central New Jersey. And then this next wave is going to be coming on through, interacting with all this tropical moisture. And again, a high potential here for some significant rainfall. Now, why are these storms moving so slow? Well, because there's not much really pushing them. Look at the upper level winds here. They are as weak as you could possibly get them. Now, by the time we get to Saturday night into Sunday, that is where we get a little bit more influence from this polar jet stream. It enhances the lifting. And look at the jet streak here that's showing up here. Okay. Now again, not incredibly strong or anything of that nature, but enough to create enough divergence and diffluence aloft to make for a more of a widespread event for Sunday for the region. So if you have any outdoor plans, Saturday is your day, and I'm going to show you why in just a few moments. At 850 millibars, you can see those strong winds as well starting to show up here. So again, just looking at the mid-level winds for this evening, overnight, there is some enhancement at 850 millibars, right, with the winds. And when we start to see that signal, that opens up more widespread showers and thunderstorms, potential for heavier downpours, potential for some of those stronger winds aloft to mix down towards the surface, which could lead to an isolated severe thunderstorm. Then for tomorrow, the jet streak blows on through. Again, we'll have to watch out for some of those stronger thunderstorms, but I think it's going to be more isolated because the lifting associated with this scenario is going to be a little bit weaker. And then we jump next to our next threat, which is Saturday night into Sunday. And there's our next strong jet streak showing up at 850 millibars. So what's going on at 500 millibar lifting? Not a lot. Okay. The short wave that's moving through tonight, there is our storm. There's our setup for our storms. Again, notice at 500 millibars, there is nothing on the New Jersey coast right now. Okay, not much in the way of lifting. Again, this shows again how mesoscale factors are driving current storms right now over central New Jersey. And then you get this next wave that is coming through with support at the upper levels with that short wave for overnight tonight. Now, the next threat that shows up for Saturday night and Sunday, again, slightly stronger, not a strong short wave. All your strong short waves are back up here. Okay. They're not diving southward yet. So we're just getting just a bare minimum in terms of the strength of these short waves. And at 850 millibars, same type of story. And I'm telling you, if we had one of these strong troughs driving into the region with all this tropical moisture, this would be a pretty significant severe weather event and heavy rainfall event. But we're not there yet. The reason why I say not there yet, watch out for, let's say, late August and September. I think we're going to have some pretty impressive rainfall events out of these cold fronts by then. Precipitant water value again tonight, very high. You know what that leads to. Again, tomorrow, same thing. A nice signal showing up here. When I look at this, again, I'm not looking at this as like something that's verbatim. Like, hey, this is exactly where we're going to see heavy rain, right here. No. What I'm using this for is saying, okay, when we have the cold front move through and it lifts this moisture, any thunderstorm that forms on this cold front is going to be able to tap into all of that tropical moisture that you feel when you walk outside. And so, what that means is that every one of these thunderstorms are going to feature the potential for frequent vivid lightning, intense downpours, hail, and downburst wind gusts. Not so much tornadoes, but I wouldn't be surprised if you get a tornado warning because right now the National Weather Service is very, very vigilant on any type of signal that shows up on the radar, any type of twist. But I think that is more driven by the downburst wind gusts creating a weather low for a short period of time, and that triggers the tornado warning. Notice, even in the last event in this highly tropical environment, we didn't have any tornadoes around the region verify, even though we had several warnings. And the reason why is that we just didn't get full development because what's happening is that there's a lot of rising and sinking motion in the atmosphere. You're having a lot of strong updrafts and downdrafts, and that is what is creating that signal that is showing up on the radar. Now, you notice on Saturday that precipitable water value falls off very nicely, which is great news because if you have outdoor plans, you want to do it on Saturday because unfortunately, Saturday night and Sunday, again, we go through the roof in terms of precipitable water values. Now we're talking about going over 2.5 inches. Sunday's not going to be pretty. I can tell you that right now. And so what I envision when I see this is basically two waves. The first wave of showers and thunderstorms on Sunday morning via the warm front, and then the second wave on Sunday afternoon with showers and thunderstorms. The potential for severe weather on Sunday afternoon will depend on whether or not we see enough clearing between the warm front lifting through and the cold front approaching. If you see sun, it's going to get interesting. If you don't, then mostly it's just going to be a heavy rainfall event with limited Cape values. But again, you can see here we are tonight. You get a nice little. This supports sunny skies on Friday afternoon and on Saturday, all the way up through Saturday afternoon, Saturday evening. Everything goes downhill. Here we go on Sunday with the warm front, and then the cold front follows through here, and then you see that potential for those thunderstorms to come through, and then probably Sunday evening, probably a pretty nice sunset with rapidly clearing skies. Let me jump to the Cape values here, and you can see where we're at right now, right? You see the type of environment that we have. And then for tomorrow, with the Cape values this high, not everyone's going to see thunderstorms, but watch out for some of these isolated thunderstorms reaching severe levels pretty easily. There's a lot of kinetic energy built up in the atmosphere, a lot of potential energy that can become kinetic energy via these Cape values. And that shows up again on Sunday. Now, again, on Sunday morning, obviously it's a little low. Of course, it doesn't show now. Let's refresh this and see if we can get new data coming in. Okay, so again, look at Sunday afternoon, not as impressive, right? Why? More cloud cover. So this may be more of a heavy rainfall event on Sunday than severe event. We have to watch this. If we get more sunshine, don't be surprised if the forecast for these Cape values go through the roof. If we get a lot of cloud cover, that Cape value is held down a bit. But still, it's going to be a stormy day on Sunday, any way you slice it. So let me jump to tonight. Now, there is our shortwave coming through right here. And after 10 p.m., it'll start to march its way through another round of moderate to heavy rainfall. This is on top of the shortwaves that are interacting. What's going to be interesting as this comes through, wow, it is really coming down hard. What will be, let me go back to the radar real fast because here's something to ponder. With these thunderstorms firing off, and we'll refresh this, there's going to be some outflow boundaries that are going to be coming out of these storms because you have a lot of rain cooled air. How will those boundaries interact with all this heavy rainfall and thunderstorms moving in from the west? It's going to be something to watch. I honestly am not sure yet. I don't think it'll be pushed to severe levels, but certainly there's going to be good potential here based on what we're seeing for some very heavy rainfall through the overnight period. So that's something just to keep in the back of your mind as you get towards midnight. Don't be surprised if there's a flash flood warning. And by the way, I am using our weather radio. I muted it because I don't want it going off while we're talking, but this is a great time to remind everyone to get your weather radio from Midland. The National Weather Service, the NOAA weather radio, to me saves lives, right? Because it works no matter what. As long as you have batteries, you're good to go. So we're using it right now, and um, I think it's something that every house should have, just like a fire alarm and a CO2, a CO indicator. I think you should also have the weather radio as well. So then, what happens after that? Well, for tomorrow, again, watch out. You see how the NAM has these isolated cells? Again, I'm not expecting widespread severe weather, but don't be surprised if some of these thunderstorms here really grow and really produce some impressive thunderstorms tomorrow afternoon and evening. And let me refresh this, see if we can get the Sunday. There we go. That's what I was waiting for. Okay, and now Saturday is absolutely Friday and Saturday is absolutely beautiful. Sunday, unfortunately, goes downhill. Saturday night into Sunday, widespread showers and thunderstorms, heavy downpours, and then the cold front follows on Sunday afternoon with additional showers and thunderstorms as threat. So again, you get a nice wave of showers and thunderstorms in the morning, and another wave in the afternoon. So that's well, I'm going to leave the radar up here while we continue to monitor the situation here. Let's dive into some of the questions. Again, as always, we answer all the questions from the chat room for premium members, and then we check out to see what's going on in social media land. Okay, so go all the way up to the first question by Jim Boris. Jim asks, okay, so mentioned this morning in the premium discussion and premium video, the negative EPO aiding and abetting all the humid heat now would enhance strong cold fronts this fall should hang in its current state. Please explain how you can give one result now and opposite result 3 months from now. Great question. Okay, so here's a general theme here. Let me pull up the 250 millibar winds. Okay, so right now, the way that the weather pattern, we're in the middle of summer. So these wavelengths are a lot shorter, right? So as a result, we're getting these weaknesses focused around, let's say, the St. Lawrence River Valley, the Eastern Great Lakes. You get a nice trough around Eastern Canada. It's all displaced to our north, right? And meanwhile, you have this dominant ridge that is taking control here, right? And basically, the influence from the negative EPO basically just locks in the weakness between the ridge here and the ridge on the Western Atlantic right to the west of us, which means you get a lot of cold fronts that come and approach, but they die out because all your strong forcing and all your strongest cold air transport is all focused in Canada, right? So what happens in 3 months from now? Well, the polar air masses start getting stronger because we start to shift towards fall. Our thermal gradients increase. And this process with stronger polar air masses and an increase in the thermal gradient overall throughout the northern hemisphere leads to broader troughs and troughs that are able to dig further south. While we still have the negative EPO in place, it doesn't produce a trough axis that's always to our west. And even if it did, it allows for the jet streaks in the polar jet stream to interact with our cold fronts more. So right now, we'll go to 850 millibars for a second. Actually, I'll go to 500 millibars. And notice with our cold fronts approaching, look at the way that the winds are aligned. Generally from the southwest, west and southwest. So, what does it look like as far as our surface? Cold fronts. Let me zoom out here. Well, there's our cold front back here. There's our upper level winds. What do we notice? The upper level winds are running parallel to the cold fronts. Why? Because your polar jet stream is focused up here. So what's happening at the surface is that these cold fronts aren't getting much of a push. So they approach, and then it becomes stationary, and you get these waves of showers and thunderstorms. You have your southwesterly flow at the 850 millibars, which we'll pull up right now, which is right here. And look at that, right from the Caribbean, right from the Bahamas, right into our neck of the woods. So you end up with this tropical air mass, cold fronts dying out, and us getting waves of showers and thunderstorms. By the time we get to the fall, let's say we have the same exact setup, same exact influences of a negative EPO. This time, the polar trough is deeper. It's able to push further south. So now you have this couplet driving these cold fronts. And so instead of the cold fronts moving in an environment where the winds are running parallel and they're relatively weak, so the cold fronts die out because they just kind of linger and wash out, now you have a driving force and you got reinforcement with polar air masses, so this leads to cold fronts able to drive through and make it to the coast. They may still stall out, but they'll stall out over the coastal waters further out, and we will have more influence from polar air masses. And this again can lead to major rainfall events. So that's why you end up with the same statistical analysis in terms like, oh, we still have a negative EPO, but it's different type of influences because you're dealing with a different type of polar jet stream environment. So that's why. Let me pull this back up. Steve, when the showers and thunderstorms Sunday morning clear the coast, particularly the Parkway corridor. Okay, when will they? I can't give a specific timing card on that. What I will say is that it looks like there's a nice wave of thunderstorms that are going to be moving through New Jersey, southern New Jersey, and central New Jersey from roughly 7 a.m. to 10 a.m. And then there might be a break from, let's say, 10 a.m. to about 2 before the next wave of thunderstorms comes in from the cold front. But again, that timing is, you know, slated to change. You know, it could come through a little bit earlier depending on the timing of the short waves. But that's what I'm thinking right now. Any way you slice it, it's going to be a bit of a stormy morning with heavy rainfall, so it's not going to be the best. Outage in neighborhood can knock out the internet because that loses the power it needs to push a signal along. Yeah, absolutely. I've had that before. We've had the generator on, but we just didn't have the internet. So that's why I mentioned what I mentioned. We'll have power, but not much internet. And sometimes the internet is still in place, so everything's good to go. But I figured I'd give you that heads up just in case. One thing I noticed is that water temps off the mid-Atlantic coast are rather warm at this point. Yes, they are. With the southerly and southwesterly wind pattern, especially the southerly wind pattern, we're seeing the what's it called, the Gulf Stream, get pushed a little bit closer to the coastal waters than normal because you have more of that south and southeasterly wind component this year. Let's see here. Point where One thing I noticed is that the water temperature along the mid-Atlantic coast are rather warm at this point, to the point where, while it won't intensify into anything tropical, it seems warm enough to prevent quick cooling water demise. Yes, that is very true. With this type of warm environment, you would have a tropical system, if it's moving fast enough, slow to weaken. It will still weaken, but if it's moving fast enough, it might not weaken substantially, and that could be a bit of an issue. We'll watch it. We'll see how that plays out. Circulation in the Gulf Stream as circulation in the Gulf seems as much over land as over water. Not exactly good for tropical development. Yeah, I'm not impressed with it. I would not be surprised if this just remains a disturbance and that's it. With a lot of heavy rain, still a lot of flash flooding. Atlantic Basin itself seems to have actives, 250 millibar jet streak, and a lot of shear. Yeah, right now we have, I guess you could call it almost like a warm neutral state in the El Nino region. We don't have an El Nino or La Nina, and for some reason, people are running around trying to make adjustments to saying like, "Well, if we adjust for global warming, we actually have a moderate La Nina." I'm like, there's literally no forcing to support that, none. It's just sure we can all adjust statistics to whatever we want to make it. That's something I learned in statistics class. If you want to find something to make your case, you can manipulate statistics to show whatever you want by making a couple of adjustments in the time period, or if you wanted to compare it to a different data set. But that's not reality, and this is why I don't like the idea of statistical forecasting. I like to understand the driving factors, the forcing factors. Um, what are the factors that are driving our meteorological equations to describe the atmosphere? I think that's a more honest way to look at the atmosphere. So I don't need to make unusual adjustments in order to say that there's a La Nina or El Nino. If the SOI is in place to support it, and if you're seeing a change in the trade winds and the pressures and whatnot, then you can say, hey, you have an El Nino or La Nina or whatever. Right now, you have nothing. And the reason why I kind of go back to that is that with a warm, neutral state in that region, it makes sense as to why we're seeing those type of winds. Again, let's go to 250 millibars, right? And let's take a look at the tropics. So zoom out a little bit and take a look at this. It's not exactly the best environment for any type of low pressure, tropical low pressure system development. You got a ton of shear running around here, especially right over the central Atlantic. So, why is this important? Okay, if you have forcing like this, my forecast of a near to slightly above normal hurricane season, mostly based on the idea that the NHC tends to like to name every subtropical low pressure system that may develop for 15 minutes. So I'm going to go with a little bit above normal. There's a chance here we might go below normal if this keeps up. We don't have any support from the MJO really. It barely moves through phase 6 and collapses before it gets through phase 7. So not a lot of support there. You're driving a lot of your tropical systems off of remnant cold fronts. So yeah, so far, fingers crossed, remains quiet. We'll see. We'll see how that continues to evolve as we move forward. How does the north central northeast Union County look for storms tonight? Right now, I would say that the concern more is about heavy rainfall than anything else. Storm movement direction yesterday was perfect to turn Washington Mountains into a water ringer that helped enhance the rainfall. Absolutely. Yeah. It got nasty. I mean, you had orographic lifting, you had convergence and confluence at the lower levels, you had upper level divergence. It was just a perfect combination for flash flooding. Uh, Paul asks, it seems that central and northern New Jersey are getting the bulk of the rain recently. Here in New York City, we haven't had that big thunderstorm and heavy rainfall like central New Jersey. Is this due to urban heat island effect? Yes, I think it is. I think what we're seeing is that gradient that is taking place. It's enhancing the storms out ahead of the gradient because the key isn't the urban heat island dome itself. The key is the gradient. So here, let me zoom in here. Okay, so you have your urban heat island effect here, right? And so you get this temperature gradients that are showing up, right, on the I-95 corridor. And those gradients are the same gradients why I'm seeing a lot of potential for those tornadoes showing up of late, right? Over the past couple of years now, we've seen like tornadoes pop up, and I mean verified tornadoes, not just radar warned. So, what's happening here? I think the urban heat effect is enhancing these thermal gradients, and these thunderstorms are basically focused on it. Now, something just to keep in the back of your mind for winter. When we actually get some impressive nor'easters and major winter storms, and trust me, they'll be back. One of the things I'm going to be watching for that is going to be very difficult to forecast for is how these urban heon gradients enhance convective snow and slantwise convection. That's when you get like that thunder snow scenario. How does that enhance that potential? And can that lead to areas where we're looking at a 12 to 18-inch snowfall, and then we also only start pushing towards 2 feet? Um, that's going to be something that's going to be very difficult to forecast for. I'm going to try, see how it works out. I got some theories on it, but they're not proven. But I think that it's going to be interesting. I think what we're seeing in the convection right now is one of those factors that I'm going to be very interested to watch. Let's see here. Didn't parts of New York City get massive flooding from the last round of rain? FDR was flooded. Parts of it, yeah, parts of it. There are some subways, but to be fair, the way that these subways are set up and the way that the infrastructure is set up in New York City, at this point, it doesn't take much to create those flooding problems. If the sun exploded, there are people who would blame global warming for it. Um, no, that'd probably be massive global cooling. But what I will say is that in this scenario, is global warming a factor? Definitely. I mean, I've been talking about this for years now. Actually, I'm pretty much one of the first ones to talk about it. Forget the temperatures. I don't care about it. It's all about the precipitable water values. The more moisture you have in the atmosphere, it drives your storms, it drives your convective potential, it drives your winter storm potential, everything. It basically describes everything in the atmosphere really nicely. And the best thing about using the precipitable water value equation is that you can translate that to heights, and then from heights you could translate that to stratospheric influences, right? So it becomes a very nice mathematical equation that you don't have to worry about anyone fudging anything or putting it by an airport or anything of that nature. It removes all of that error and all that wishy-washy stuff. And actually, in the Boise conference I went to, I actually got a chance to talk to Climate Central. And I said, look, guys, with all due respect, everyone can see that your chart ends in 1950, and that's where you have your pushback because everyone's like, well, what about the 1930s? And it throws out your skewing of your temperatures, right? So remove the temperatures and look at precipitable water values because your humidity was not as high during the Dust Bowl, and obviously dust, but during the heat waves during that time period, right? And you can look at that worldwide. And that is a far better argument than saying temperatures because, one, there is no average temperature. Okay, that's very difficult to do for the whole Earth. And two, you have a lot of debates in terms of where was the station put, what was the way what was the best way to make sure that that data set didn't have unusual errors. How are you adjusting temperatures? Why is this falling? Why is this rising? Why did you make these adjustments? You can remove all that nonsense and go back to just precipitable water value and seeing how that changed with pure math and the equations work. And so I always say, whenever you add something to the atmosphere, there's always an equal opposite reaction. Now, combine that, you also add in the influences from volcanoes like Tonga. That was more of an influence on the stratosphere, as you know. You know how I've been watching it very carefully. Now it's starting to subside a bit in terms of the influence, but this also has an impact on the overall composition of the water vapor in the atmosphere, which of course is a major warming agent. That is something that we all have to recognize. But in terms of precipitable water value, this is a focus more on the lower portions of the atmosphere, usually from the surface up to roughly 600 millibars, which is what you want to look at. And that's why I find it very interesting. Uh, if negative EPO, here's Donald Dodd. If the negative EPO persists deep into the fall, enhancing cold fronts, as you mentioned earlier, live chat. Would you expect this result in greater frequency of high wind storm events? In other words, should I get my high canopy oak and maple trees trimmed? I would do that anyway, just because of the tropical concerns I have. To be honest with you, better now than wait for a severe event or having to rush and then you get price gouged. Let's be honest, it happens. Um, with the QBO going into an easterly state, and with the way that the stratosphere is evolving, and again, we got to watch this because I can't believe that the stratosphere is going to remain the same as it is right now. And of course, with influences like stratospheric warming and with a stronger negative QBO taking shape, there should be some adjustments in the position of the EPO. But in the case that this remains in place, this signal would then lead to a stronger signal for a negative EPO, a negative NAO, should I say, which right now in the model guidance is going more neutral. So this would, in theory, lead to more storms in the fall and certainly more nor'easters. But it's something that we have to really study and see how things evolve. I am just far enough west of I-95 and just elevated enough that we have gotten some real enhanced snowfalls from nor'easters. Happens with every big blizzard that hits New Jersey portion of the New York City metro, combines with winds off the ocean, New York Bay, and lifts up through the heat island into the cool air. You are in a location where you have a combination of orographic lift, convergence, confluence at the lower levels, and divergence in the upper levels to really enhance your snowfalls. Typically, in usually like this area right here, you get a nice band that surprises a lot of people. Sometimes I get this right, sometimes I don't, in terms of nailing that heavy snowfall. But usually, someone in this area here gets a surprise heavy snowfall out of this. Let's take a look at social media. We'll start off first with YouTube and then see the rest. Last year we were bone dry. That's true. Looks like a break from the humidity Friday into Saturday afternoon. Yes. So if you have any outdoor plans, I definitely would say definitely check that out. Let's see here. I don't see this pattern breaking down anytime soon, by the way. So, and in fact, this might be all the way into the fall. Yeah, I know. Is the rain going to stay in LA, Texas, or is it going to get sucked up the cold front? I think what will happen is that it'll interact with the cold front, but it won't really get to our neck of the woods. It'll probably rain itself out over the Tennessee River Valley. The urban island effect is keeping storms to the outskirts of New York City. Then why is Philadelphia getting slammed by every storm? Okay, so this is a factor of not only the urban heat island effect, but the topographic, right? The orographic factors here. Okay, so what do we have that Philadelphia has? What does New York City have that Philadelphia does not? Well, Philadelphia, you have lower terrain here. You don't have as steep of a decline in your orographic features out here, right? It's a little bit flatter. New Jersey, though, northwest New Jersey, you have a lot of hills and mountains, right? And so when the air comes off of this region here, it tends to sink. Combine that with your water, right? You have your urban heat island effect, but you also have your cooling effect from your oceans. So you have more diverse gradient here and more potential for subsidence with air coming off of the Hudson Highlands. So New York City, from a mesoscale and microscale factor, is far more complicated than Philadelphia. Philadelphia, you have a lot of your storms usually coming in from York or coming in from Lebanon, somewhere in this area here, passing around Reading. The decline in elevation in this area is far less impressive than up here. So your thunderstorms are able to remain strong when they're approaching Philadelphia. So as they're approaching Philadelphia, you don't have an ocean around Philadelphia. You have the Delaware River here, right? So you have a gradient here, but not here. So when these storms approach, they get stronger here with a moderate gradient, but when they get here, that influence from the Delaware River allows the storms to get knocked down a little bit until they get to about the Pine Barrens and where they amp back up. So this is why a lot of people would complain in southwest New Jersey, hey, I missed out on a storm, I didn't get a heavy rainfall because of that microscale factor. So this here is far more complicated because you have a lot of competing boundaries here, uh, and you have subsidence coming off of the Hudson Highlands. So you have all these factors interacting with each other, and sometimes they cancel each other out. You don't have as much of a complicated factor in Philadelphia, and that's why you're seeing the difference. Anything on X or Facebook? And one other thing too, New York City is right on a stable layer of the ocean. That's why it's hard for severe thunderstorms to really get going around Long Island. So that's a factor as well. All right, question. Seeding. If you seed a cumulus cloud, updraft is there, eventually will precipitate, but it wasn't ready to condense yet. Does this take away from downstream rainfall convection? E.g., seed a cloud in Austin takes away from Houston precipitation, or is it scale too small? The scale for cloud seeding is basically micro. Okay, we're talking about individual cloud. It doesn't have any impact on other clouds. This is why the idea that cloud seeding enhances rainfall of a major flood event or impacts Texas rainfall overall is just fiction. And it shows a lack of understanding. Not you, but I'm just saying that general people that believe that a general misunderstanding of the science and what we're capable of doing. Cloud seeding usually is based off of focused on a cloud that happens to be over one area. You try to seed it to enhance the potential for precipitation. It really doesn't create a heavier precipitation, it just enhances it. So when you have this, let's say in the winter around our neck of the woods, let's say around the Poconos, and you know that you have some lake effect going on, and you have a snow flurry coming in and you want to seed that cloud to enhance the number of snow crystals, what you're basically doing is creating a what we call a cloud nuclei, okay, which is basically your platform to build snow crystals. It's the same process as to why we see more precipitation in high pollution areas, because you're putting more particulate in the atmosphere, and thus you have more potential for cloud particulates and cloud nuclei to grow and more precipitation to fall. Again, this factor. So really, man has been cloud seeding for as long as, let's say, we've been using fire. Okay, that's the truth. We just don't have the power to create any type of dynamic environment or anything where it enhances anything or influences anything miles and miles away. Tornado warning, Manchester, PA. Correction, Maryland. Oh, okay. Let's take a look. Uh, let's see. Let me put back on the watches of mornings. Let's go find this. There we are. Now, I'm curious here if I could pull up a radar on this. Let's see if I can pull up a closer one. Maybe this one might have it. We'll try Delaware next, but let's take a look and see. Let's see what we got here. Okay, so very weak. Not the best signal here. It's very marginal. Very marginal. So it's probably right about here. Okay. Now, when I see this, I don't say to myself, wow, major tornado. But obviously, Let me go back. Let me pull off the warning here. Okay, so there's our signal. So this is what's going to trigger your warning on the radar. You got your rotation right here. Okay, so you have winds moving in different directions right here. It is circulation. When you look at the cloud, the actual cell here, not exactly a typical tornado signal here, but certainly one for a mesoscale low. So let's try, let me add something else here. Storm tracks. Now, notice we don't have any TVCs. This TVS usually is a signal of an actual strong mesoscale low. We have storm cell. Let's see here. See, no TVS. We have a mesoscale though. Look at this, meso 3. Okay, so there is clearly sign that this cell is producing a mesoscale low. Again, no TVS at all being signaled. Mesoscale low though. Let's see, what else do we have here? So you know what I think is happening here? This is going to be another example of downburst wind gusts. This is going to be another example of that. Okay. So this is why you put out the warning, because you see this and you say, hey, look, circulation. But what I think is happening here is that updraft, very strong, downdraft, very strong. Why? Where is that happening? Right on the back end of this storm. Now, you could pull off a tornado if you had this structure far enough away from it, um, where you get a strong enough circulation. But I don't think that you're going to get, if you see a tornado out of this, it might be an F0. But honestly, I'm not seeing anything that really shows up as a strong mesolow. And here's a signal here to watch. Notice that your circulation really isn't tight at all. This is clearly a sign of something where you have sinking air moving away and you have rising air here. What I would want to see in terms of a tornado is this much tighter, like the dark reds and the dark greens, like literally right next to each other. That's a sign of a real strong circulation here. Let's see here. Well, we do to some extent, but use of nuclear weapons is not suggested. Well, that's true. Let's see. We have anything else? Couple was a bit tighter a few frames ago. Yeah, you see, here's the thing. I think that for me, again, we have to see what the National Weather Service finds, okay? But here's a theory I have. I think that it's understandable to put out the warning because you never want to lowball warnings. You never not want to put a warning out and then something's actually there. But I think what's happening here is that our radars have gotten so good in picking up these updrafts and downdrafts and the movement of the winds in these thunderstorms so well that we're going to have a lot of false positives because we're seeing so much now in the storm structure. But because this doesn't remain very long, in my experience when I was in Oklahoma, when a tornado got going, it just didn't fade away and collapse like 15 minutes later. It just keeps on rocking and rolling. It builds. And I think that in this scenario, and let's see if we can refresh this, see and get any new data. Yeah, this is definitely a weaker signal as we move forward. And you see this here, this is the other thunderstorm cell. So it's going to be interesting to see if this just completely overwhelms this whole circulation. So a lot interesting, very interesting. We'll find out soon. And look at this. This is just about to get wiped out by this cell down here. So basically these strong winds here are driven by this storm here. And so even with that notch, I mean, there's a very, very weak notch, if anything, out here on the radar. And it's already getting overwhelmed. So I don't think that this is going to remain warned very long. Let's see. Go back to watches and warnings. Yeah, I would not be surprised if this loses its warning in the next 15 minutes or so. But interesting case study nonetheless. Okay, let's see here. Do we have anything else? If you could take a look at the radar specific differential phases, what do the different colors mean? Okay, so just fair warning here. Being colorblind, I'm not the best in terms of the differential phases with the radar. It's something that is very difficult for me because I see red, black, white, and gray. So that makes life challenging. I've learned how to deal with it. But let me see if I can pull it up here. Velocity. So differential phase. I tell you what, let me get back to you next week so I can do this properly. Okay. I think that would be a smart thing to do. If the storms merge at different directions, can that create shear that enhances the downdraft winds and even causes some circulation? It can happen, absolutely. That can definitely happen in if you get the storms to phase just right and basically come together. Here we got this new data here, and wow, look at the strength of the outflow with this thunderstorm. I would not be surprised. Hmm, this is going to be something to watch here as these interact. They might have dropped a warning. I'm not seeing it showing up anymore. Yeah, it got overwhelmed. That's exactly what happened. Yep, it's just getting overwhelmed. I wouldn't be surprised if they issue another tornado warning though off of this, as this phases, and probably put it up here and have it directed this way. But this storm's just getting absorbed and crushed by this one. Yeah, I wouldn't be surprised if something tries to form right out here. Here's a cell, it starts to organize. That's going to be interesting. See that take shape. Watch for right here for a new warning to get issued based on what we're seeing. Let's see here. Luckily, nothing like that over our neck of the woods. So that's certainly some good news. So, one thing also, let me zoom out here. When you have this storm complex here, and let me take off the storm tracks for a second. So this northern edge is what's going to move through New Jersey. This feature is going to head towards New York City, more rain than anything else. This feature right here with this nice bow echo, this is something that we're going to have to watch out for towards midnight for Delaware, southern New Jersey, talking about Cape May, areas like that. And now it's just a severe thunderstorm warning. So we dropped the tornado warning. It's just a severe thunderstorm warning. Um, but this looks like a nice storm that's going to definitely create an issue for southern New Jersey towards midnight. So that is certainly going to be interesting. Looks like we answered all the questions. Let's see here. Oh, what time do you expect the rain to hit Union County area with this path? A lot of it towards midnight, overnight. I think Union County won't see as much rainfall as we will see in southern New Jersey. I think this time the focus is southern New Jersey, not so much northern New Jersey, as that it appears to be where a lot of your divergence and diffluence is focused. So a lot of this is going to be moving through between, let's say, 11 p.m. in our eastern zones to, should I say, western zones to about 2 a.m. in our eastern zones, gradually moving through. And I think that's it for tonight. We've had a long night. Is there any other questions on social media? No, that's it. Okay. So definitely a great discussion. Again, thank you once again for all these great questions. And as always, Stay safe out there.